Good morning, everyone. My name is Justin Sears, Product Marketing Manager at Hortonworks. It's my pleasure to host our 7-webinar series entitled Discover HDP 2.1, covering all the new capabilities for Enterprise Hadoop delivered in Hortonworks Data Platform version 2.1. Today's Apache Solr for Hadoop Search is the 5th webinar in the series. If you missed any of the previous 4 webinars, you can find those recordings, slide decks, and Q&As on our blog. Just search for Discover HDP 2.1. I'll be your host today, and I'm joined by 2 Apache Solr experts. Rohit Bakhshi is a Senior Product Manager at Hortonworks. He is responsible for Apache Hadoop and Apache Solr in Hortonworks Data Platform. Paul Codding is one of Hortonworks' veteran solution engineers. He is based in the Minneapolis area and focuses on helping enterprise customers succeed with Apache Storm and Apache Solr. Here's today's agenda. We'll begin with an overview of Apache Solr and Hadoop Search. Then we'll do a demo, and we'll finish with time for Q&A. We've got 30 minutes, so we're going to move quickly. All attendee phone lines have been muted. If you have questions during the presentation, please send them to Paul Codding in WebEx chat. We will take time to answer those at the end of the call. If we do not have time to answer all of the questions, we will include a full Q&A in an upcoming blog post about this call. So let me set the stage for Rohit and Paul. This is a modern data architecture to store and process data from a wide variety of sources. Data comes in structured columnar formats and also newer, less structured formats like those found in human-generated content such as Word documents or videos, in weblogs and clickstreams, in social content like tweets, and in machine, sensor, and geolocation data. You see these newer data sources down at the bottom. Apache Hadoop works well in combination with familiar data repositories like RDBMS, EDW, and MPP, to store and process a full spectrum of data. That data is then available to a variety of data access applications and BI tools to complete many different data workloads: batch processing, interactive queries, stream analysis, NoSQL search, and others. Through our experience with more than 200 enterprise customers running HDP, we know that enterprises need 3 additional capabilities to be integrated with data management and data access you see in the core here of Hadoop. They need data governance and integration, they need to secure their Hadoop cluster, and they need tools for cluster operations. In today's webinar, we will focus on one of the tools for data access in Hadoop, Apache Solr for Hadoop Search. We will cover other components of Enterprise Hadoop in the last 2 Discover HDP 2.1 webinars over the next 2 weeks, and you can look up details on the 4 we've already done on our blog. So now I'll turn it over to Rohit Bakhshi, who will give an overview of search in Hadoop, and then Paul will show a demo. Please remember to send your questions to Paul in chat. Take it away, Rohit. I'll pass over control to you.
Great, and we're good to go. So good morning, everyone, and good afternoon, evening for people all across the world. Really excited to be here. My name is Rohit Bakhshi. Justin, thanks a lot for the introduction. I'm excited to be here with Paul Codding to talk about one of our newest set of functionality that we brought online with HDP 2.1, and that's HDP Search. So let's start with why. Why do we look at search, and why is it important to our customers? So imagine a scenario where if you're familiar with Hadoop and the Hortonworks Data Platform, what you can do with this scalable data management platform is you can store all your raw, refined, in-process data in HDFS, which is your redundant, reliable storage layer for all types of enterprise data. And then you have a processing platform on top of that, tightly coupled with HDFS, that allows you to run processes and run queries and transformations and different types of processes on that data at scale. And so with that, you have the platform for what we call a data lake, where you can load in all your different types of raw data, structured, unstructured, multi-structured data, and use different interfaces to query and process that data and analyze that data, and then serve it up to your BI reporting or custom analysis applications. And so with data in HDFS and the Hortonworks Data Platform, you have the ability to run transformational analysis through MapReduce, through Thales. You have the ability to run to enable your business analysts to write SQL queries and do interactive analysis through Hive and Days on that data, you have the ability to serve it up to large-scale web applications or large-scale reporting solutions off of HBase, and to use Storm and streaming as a streaming process layer for data that you're ingesting into the data lake. So you have all these different interface points to data in HDFS that leverage the processing infrastructure through Yarn. And what we've done is we said, there's a type of access interface where you have the need to take documents, take text information, take log information, and provide a way to use text queries, natural language queries, to run analysis and run queries and explore and do reports off of that data. And that's why we invested in Search. And that's what Search really brings. It brings the capability to meet different types of use cases, and Paul, through a demo, will show one of those use cases. It also expands the access to the data lake, to the Hortonworks Data Platform, to a large set of users who are very comfortable writing natural language, English, different languages, queries to access and really massage and use the data and query the data. And that's the power of bringing Search. And it's the power, and our approach is to bring Search into the platform where it leverages the scalable processing and storage power and capabilities of the Hortonworks Data Platform. So how did we do it? What's our approach to bringing Search into the platform? What we did was we looked around and we looked at the best, true to our roots, the open source platforms available to provide this type of capability within the Hortonworks Data Platform. And as we did our search and as we looked at different solutions, Apache Solr really stood out. Apache Solr has been around for a few years. It's widely used, probably the most widely used enterprise search platform that's open source. It's a very feature-rich platform for rich text-based querying of data. And it's actually used today by enterprises all across the world to power things like web search, to do process analysis and analysis on data already. And so what we're doing is we're providing support for Solr as part of the Hortonworks Data Platform. And we're doing that in partnership, and we partnered with Lucidworks. And Lucidworks is a company that actually has the most expertise behind Solr and Lucene, and provides that expertise as support to enterprise customers. And so that's what we've done. We've entered this partnership with Lucidworks. Lucidworks has committers for Apache Solr, which is the component that we're including as a supported component in the Hortonworks Data Platform. And so with Lucidworks, we can provide enterprise support for a search platform that lets you analyze and query data living in the Hortonworks Data Platform through search queries. And so that's very exciting. We're excited to partner with Lucidworks. So let's drill into what it means to have how we're providing this open source search platform for the Hortonworks Data Platform. So it really breaks down into two major components. There's Lucene, Apache Lucene, and Apache Solr. And so let's spend some time talking about that. Apache Lucene is the library, the Java library that really forms the power of the search capability in HDP Search. What Lucene does is it provides the indexing capabilities to convert raw documents. Let's say you have PDF documents or you have Word document. The ability to index those and provide them as a index document so you can then power searches and search queries. So Lucene has a bunch of functionality that's very standard to search platforms. It lets you do rich querying where you can do highlights of results. You can do faceted searches and for drilling into different categories in the data, in the raw documents. And Apache Solr builds on packages Apache Lucene, and Apache Solr provides the search platform, so the scalable, linearly scalable search platform that uses the Lucene indexing, Lucene search query serving capabilities, and provides a way for you to run and submit queries over REST, so over HTTP and XML over REST, and even to Java clients and applications that need to query and execute search queries leveraging the Lucene library. And so with that, now you have a search platform where you can submit HTTP requests and are able to execute queries against index documents. Solr provides administrative interfaces. It provides monitoring capabilities through JMX plugins. And so with Apache Solr and Lucene, we have an enterprise search platform available that integrates with the Hortonworks Data Platform. Now, in addition to Solr and Lucene, what we provide is an indexing connector that actually hooks in to data in the Hortonworks Data Platform. And so using this indexing connector and this Hadoop connector, this is available through HDP Search. It's available for download. And it allows you to take raw documents that are living on your HDFS cluster and at scale, index them and create index documents that are stored as Lucene indexes on HDFS as well, or on Solr instances. And so it helps you navigate all the different schemas and the different attributes that come as part of different types of documents, raw documents, so CSV files or Office Word documents or zip files or log files, PDF files. All of these files can be stored, can be accessed and indexed at scale through this indexing connector. And this indexing connector allows you to plug into your existing transformational workflows. So if you're using Pig, and eventually we'll add Hive support, where you can run Hive or Pig queries and use this to take the output of those queries and create indexes in Solr. And so with those different components, the reference architecture looks like this, where you have, just like you use Hadoop today, where you store a lot of your in raw documents that are coming as you want to process and analyze, you store them in HDFS, right? These could be HTML pages, PDFs, this could be any kind of document. And you use the indexing job to continuously index those raw documents coming in and create them as index documents so that your Solr servers can then leverage and pull from those index documents and serve search queries being submitted by different types of applications, by users through different clients. All those applications and clients will hit the Solr servers and serve up the search queries based on the documents that you've indexed and stored in HDFS. And so that serving capabilities leveraging Apache Solr and Apache Lucene inside to provide that indexing and querying support. And with this architecture, you can actually deploy Solr in a distributed mode, which is called Solr Cloud. And what that does is it allows you to leverage service Solr Cloud, which gives you fault tolerance across Solr instances, as well as parallelize and scale up the amount of queries you can process at the same time against your Solr instances. And with that background, I'm going to hand it over to Paul. So I'm going to pass the baton to Paul, and Paul's going to walk through a demo to showcase how this actually works and what it looks like. Over to you, Paul.
Great. Thank you, Rohit. So can you guys see my screen?
Yes, we can.
Excellent, excellent. So hi, everyone. My name is Paul Codding. Like Justin said, I'm from Minneapolis. I'm a solutions engineer here. And today we're going to be taking a look at a demo of how we can use Apache Solr to both process and index and eventually visualize, essentially, Apache log data, right? So for this demo, we're going to kind of focus on how do we take a look at 3 years worth of clickstream data that I have stored within HDFS. It's going to be based on the Apache HDP server. There's a common access log format. I've taken that data from a remote web server, and I've just put that into HDFS using just a standard HDFS put. There's lots of different ways that we could get Apache log data into HDFS. We could use Flume, we could use Web HDFS. There's a myriad of other ways. In this case, I've just taken a lot of those access logs, shoved them into HDFS, and what I really would like to do is parse them so I can identify, what's an IP address, what's a request, what's the status code, and then eventually index that data within Solr so I can more easily kind of slice and dice the data, look for different requests from different IPs, and really the goal is to try to get a general understanding of what's been happening with users requesting data from my website essentially over the last 3 years. Do I have any anomalies? Who are the most active IPs, et cetera? Really, I just kind of want to perform some discovery type of analytics on the data. and boot rapidly. And so that's why I've chosen Solr for this. I also want to do that visually, right? And so what I've done is taken that data, put it in Solr, as we'll see how, and visualize that with a great product for HDP called Banana. And we'll take a look at all of these in the process as we go through the demo. So if you look at the source data set that I have, it's just the Apache server logs. I have just a one-line kind of snippet here of the actual data. But we can see that there's a number of different fields within this log. We have an IP address, the date the request was issued, the actual request, so it was a GET request for the root resource. I can see things like the response code, how many bytes were transferred, and the user agent string, which is part of the browser, which identifies what's the operating system, what's the type of browser, the version, etc. All this data is delimited by space. If I don't have any data for a specific field, I get just a minus character, essentially. So in looking at this, I can really determine there are multiple different fields that I'd like to be able to pull out of these logs, and I'd like to index. The goal is for me to be able to say, I'd like to see all the requests from a specific IP for a time range. In order to do that, I have to parse that data. I have to actually delineate an IP address from a request, from a status code, etc. And for that, we can use Apache Pig, which we'll take a look at. So from a process perspective for this demo, we're going to look at a number of things, but we really need to start with looking at how do we actually create a schema within Solr so I can start indexing these events. And so what we're going to do is take a look at one of the collections or cores that I created within Solr. We'll look at the schema that I created, and then we'll move on to processing that data with Pig, indexing it, and then visualizing it. So if we take a look at the Apache Solr admin interface, we can see just the general dashboard here that I have. It shows the status of the system. I just have a one-node installation on my Hortonworks sandbox. If I go to the core selector, I'm going to go to Access Logs. Access Logs is a core that I created. A core contains documents. Each of those documents have a specific schema that represents the discrete fields that I can actually store and subsequently search on. So what we need to set up first is we have this core. Now we want to see what are the fields that I've set up for each of those documents. And to do that, I can take a look at our schema XML file. Within our schema XML file, we have a section for fields, and you can go ahead and zoom in on this. You can see the fields that we've asked Solr to store about the data that we're going to actually ingest. In this case, we can see things like the remote IP address, the remote log name, the time of the event, the actual requests. Those would be a GET request or a POST or a PUT, etc. The status, like just a normal HTTP status, 200 OK, 302 redirect, etc. And then information about the browser, because that's important. We want to see our iOS users visiting my site, our Chrome users, etc. And so these fields really, like I said, compose the discrete fields that I can actually store and search on. And so we have that set up. We have our core set up. Now the next step is how do we get data into Solr, right? That's what we're going to take a look at using Apache Pig in this case. To be able to, in parallel, process those log files, parse them out, and then really stick them into Solr. And in order to do that, I need kind of a bridge between Pig and Solr. And that bridge is really given to us by LucidWorks and their Hadoop connector for Hortonworks. It's available from the LucidWorks website. And in this case, it's just a jar that I've downloaded. I'm going to register that so I can pull it into the Pig class app. And now we need to look for and pull in the actual access logs that I have. So in this case, I'm just loading my access logs. They're in this directory. Using a text loader, I'm going to load the entire thing as just one big line. In order to be able to split those fields out of those lines, so in order to split out the IP address, the remote, the headers and things of that nature, the requests, I'm going to use a regular expression. And this regular expression is just going to pull out those specific fields and give me the ability to then push that data into Solr. So once I have that data in Solr, I can start actually querying it. So I've already run that Pig script. It's parsed the data, pushed into Solr. Now I get the ability to query it. So I can query this via the REST API, or I can just use this interface. In this case, I'm just going to use the interface to query everything. So I'm going to see how many documents do I have. In this case, I have about 1.6 million documents, so I can see those specific fields here. But this is great. I could search this all day long and see a lot of JSON output or XML output. But what I'd really like to see is some graphs, some tables, because that's I'm a visual person. And for that, we're going to use a component of the LucidWorks Silk stack called Banana. The Banana is a kind of self-service interface that allows us to throw a web application on top of that Solr API and do some quick visualizations and drill downs. I have that installed, and I've already created a Banana dashboard here that helps me understand kind of a bird's eye view of what's going on with my data. So at the top left here, I have our time window. This really shows us the scope of, how do I kind of drill into specific time ranges of data. The query, so if I want to search for individual IPs or requests or anything like that, I can do that here. And this shows us the number of discrete events that we have. And then this is going to show us the distribution response codes, how much data was transferred, and what are the most active IPs on my website. So in this case, I can kind of drill into any of these sections here because I do have a spike that I'd really like to kind of do some discovery work on. I'm not sure why there's this huge spike in traffic. So within this event counter, I can just pull the time ranges I care about and start drilling into them. As I start zeroing in on this anomaly, I can start seeing all the rest of the graphs adjust based on these filters as well. And out of this, I have the one IP address that looks to be pretty active. So if I wanted to just focus just on an IP address, I can click on my little search icon here. It's going to drill into just this IP to the time range. I can take a look at what are the requests that were issued. In this case, I have a lot of the same requests. These are all to my login page. So what this appears to be is basically a brute force login attempt on the website. So we can see a lot of requests over about a 4-day period. And this is helpful in helping me understand why do I have this huge anomaly here. So if I wanted to just X out, say, okay, I know there's an anomaly. I want to discount this IP address. I can click on this action that just takes it out. The filters is just a running list of all the different executions that I've made to say filtering data in, filtering data out. And so if I look back at my 5-year period, I can now see my anomaly has been kind of pulled out. So long story short, and what we've really been able to kind of accomplish here is taking raw access logs that we had in HDFS, parsing them with Apache Pig, using the Hadoop connector from Lucidworks to be able to pull that data into Solr and then easily visualize it with Kibana. So for a lot of my customers, this is a very powerful tool, right? They have a lot of data stored within Hadoop, and they want a quick way to be able to just kind of drill into that data and search on it in Apache Solr, combined with the components within the Hadoop ecosystem like Pig and MapReduce help us do that incredibly effectively. So with that, I'll go ahead and kind of turn things back over to Justin.
Paul, do you want to queue up the first question?
Yeah, definitely.
Here, I can. Yeah, Paul, do you want to go ahead?
Yeah, sure. Yeah, so one of the questions that would be a good question for Rohit is around the projected time frame for the Solr integration with Hive, and any details on that.
Sure. So we're actually looking at getting the Solr integration with Hive done in the next few months. And so it's going to look similar to what you saw with Pig, where you'll be able to do an output from Hive and store and create a Solr index. So it's a very similar flow of running your web queries that do transformations or loading of data, processing it through Hive, and then you can write out to an index in Solr. And so as we get that integrated into the product, we'll have documentation and walk you through how to use that. Good question.
Yeah, the next question was around where the data is actually being stored, the index data. And so there's multiple different options that we have. That's kind of the beauty of this integration. We have the ability at a kind of per core basis to say documents within this core should be stored on HDFS, or documents on this core should be stored on local file system. And so in this case, I'm just storing the documents on my local XFS volume that I have attached to my sandbox. But I could have easily just said, hey, you know what, I'd like that index data to be stored within HDFS as well. And then the next question was, oh, go ahead, Rohit.
So I was going to say, yeah, another question that came in, I think for you, Paul, you can take, and then I can answer after that, is why would I use multi-node Solr? So if the data is being stored in HDFS, which is a distributed file system, and it's already distributed, the indexes are stored in HDFS as well, why would I look at Solr Cloud? Do you have some thoughts on that?
Yeah, definitely. That's a great question. I think, when we look at search, there's multiple different problems we're trying to solve, right? Just being able to store that index data, those leucine segments in a distributed fashion is great. We can do that on HDFS, but one of the big values of Solr Cloud is to be able to distribute not just the storage data, but really distribute the actual indexing process, as well as sometimes more importantly, the search process itself, right? So just like Apache Hadoop is a distributed system, we have distributed file system, distributed compute. Solr Cloud gives us a distributed both indexing and search capability, right? So as our search needs expand, as we have more end users or more applications that need to be able to hit these indexes, how can we scale that out? That's really the value of Solr Cloud, being able to scale that out.
Great. And the next question, this is for your demo, Paul, that you showed. The question is, how much data was pre-indexed and how much was done on demand?
Yep. So in this case, I had a series of files. There's about 500 megabytes that comprise the last 3 years of access to one of the blogs that I help with. And I did a one-time index, right? And so in this case, I just ran that pig script once. I think it took about, on my VM, it took about 3 minutes to index all of that data. And once it's indexed, then I can pivot, I can use Banana, which is the tool I was using for the visualization, to operate on that index. So the indexing events are discrete events. That was another question I think came in, was around, is ingestion real time, is it batch? Really, to think about it, there's lots of different ways to do it. It depends on your use case. For the type of log analysis that we were looking at in this demo, it would be most likely a more batch-oriented operation. So I might have Flume on the edge of my network pulling my access logs in, and then I would have a schedule with something like Uzi to say every hour, every 2 hours, every night, index the logs that come in from that time period. It really depends on how fast do you want the events that are being generated to be able to be searched, and how do you manage that gap. That'll really depend on, do you do indexing on a per event basis using a streaming solution like Apache Storm, or do you batch it up and use something like Pig to do it once every hour?
And I think we have time for one last question, guys.
Okay, so one last question that I got, what version of Solr does Hortonworks support, and how do I evaluate and learn more about it? So this next step here, I really encourage you to download the HDP 2.1 sandbox that Paul was showcasing in his demo. And we actually support Apache Solr 4.7.2. And so we actually have a tutorial online where you can take the sandbox, download the bits, the Solr bits and the connector, Hadoop connector, and run through an example and see and play with the technology and see how it works. And so I'd really encourage you to do that with the sandbox, HDP 2.1 sandbox, and Apache Solr 4.7.2.
And that's available on our website.
Back to you, Justin.
All right. Well, thank you, Rohit and Paul, for taking time to share your expertise around Apache Solr and Hadoop Search. That was a fantastic demo, Paul. And I also want to thank all of you attendees for taking time today to learn about Search in HDP 2.1. If you haven't signed up for the remaining 2 Discover HDP 2.1 webinars, you can do that from hortonworks.com/webinars. Next Thursday, June 19th at 10 a.m. Pacific Time, we'll hold the 6th webinar in the series, Apache Storm for Stream Processing in Hadoop. I hope you can join us for that next week. And I'll remind everyone that we will post a blog next week with any remaining Q&As that we didn't get to on this call, as well as a recording and the deck from today's call. So I hope you can join us for the next webinar next week, and this ends today's webinar. Thank you very much.